In this video, we're going to look at using antiderivatives to figure out the antiderivatives of basic trig functions such as sine, cosine, tangent, and also using them in exponential antiderivatives. So let's look at a basic trig function. Let's see. Let's take the antiderivative of, say, sine x plus cosine x dx. Can't forget the dx. Now this is the same thing. We're basically taking the antiderivative of both sine x and cosine x. You can also break it up, make it the antiderivative of sine of x plus the antiderivative of cosine x dx. This way you can look at it this way to make it a little bit easier. And let's go ahead and solve for the first part, which is sine of x. Now all we need to know is the derivative, the antiderivative of sine of x. Now what gives function, when you take the derivative, gives you sine x? Well, that's easy. You get negative cosine x. So the derivative of negative cosine x is sine of x. If you look at it this way, the derivative of cosine x equals negative sine x. Now if you switch the signs, the sine of x becomes positive and the cosine x becomes negative. So we got the first part, so negative cosine x plus, now we have to we'll find out what function we can take the derivative of gives us cosine x. Well, we know that if we take the derivative of sine of x, we get cosine x. So we have plus sine of x. And we can't forget the constant, so plus c, and that's our answer. The antiderivative of sine of x plus cosine x is negative cosine x plus sine x plus a constant. Now let's look at another problem. It's going to be a exponential problem. Let's see. Let's start off with something easier. The antiderivative of e to the x plus 1 over x dx. Can't forget the dx. So let's go ahead and just take the sum of the antiderivatives so we can break it up. So let's take the antiderivative of e to the x dx plus the antiderivative of 1 over x d to the x, or dx, sorry. So let's go ahead and figure this out. So what derivative do we need to take to give us e to the x? Well, we know that if we take the derivative of, say, e to the x, not equal signs, e to the x, if we take the derivative, we get e to the x. So if we took the antiderivative of e to the x, it'll just be e to the x. So we have e to the x plus, okay, now we need to figure out what derivative do we need to take to get 1 over x. Well, we know that ln of x gives us 1 over x, but since this is antiderivatives, we need to make sure we're taking the absolute value because we need a positive value. So it'll be ln of x plus a constant. We can't forget the constant because we need to make sure we have all numbers accounted for. So that is our answer, e to the x plus ln absolute x plus c.